Hey, this is Mr. Janes. In this video, we're going to be talking about the properties of quadrilaterals challenge worksheet, the tier 2 or 3 worksheet, starting on the back side, page 2. Let's take a look at questions 14 through 18 to start. Now, questions 14 through 18 all deal with the same diagram on the worksheet. So it's important that either A, you use a pencil and so you're able to erase and use this diagram over and over, or B, get a scrap piece of paper so you can draw this diagram multiple times, just like I have right here. Let's start with 14. If the measure of angle BAF is 28, so BAF is 28 degrees, what is the measure of angle ACD? That's this angle right here. Well, if you notice, get a highlighter out, you notice that AB is parallel to DC, and that line AC forms a kind of transversal here. Now, hopefully you remember that when we have two parallel lines and a transversal, that the angle 28 degrees and this angle here are alternate interior angles, which means that angle ACD is also 28 degrees. They're congruent. 28 degrees for 14. For 15, measure of angle ABF is AFB is 16x plus 6. So AFB is 16x plus 6, and that's this angle right here. Well, do we know anything about a rhombus that can help us in this situation? Well, we do know that the diagonals are perpendicular in a rhombus, which means that this is a 90-degree angle. And that's all we really need to know to solve this problem. We can write the equation 16x plus 6 equals 90 degrees. Again, because the diagonals of a rhombus bisect each other. Now, if you solve that equation, you should get x equals 5 1/4, or 5.25. So your answer is either 5 1/4 or 5.25 for question 15. For question 16, measure of angle ACD is 34. ACD is 34 degrees. You need to find the measure of angle ABC. ABC. So this whole angle right here, you need to know. All right. How are we going to do that? Well, there's a few options you can take. One option is to recognize that in a rhombus, the diagonals bisect the angles, which means if this is 34 degrees, this angle here will also be 34 degrees. And the total angle here, altogether, will be 34 plus 34, which is 68. Since this is 68, we can get the angle up here, because remember, consecutive angles in a parallelogram are supplementary. Again, that's because we have these two parallel lines, AB and DC. We have this transversal. And so these are two same-side interior angles. So this whole angle and this whole angle here should add up to 180 degrees. 68 minus 180 degrees leaves us with 112 degrees. And that is the angle, that is the measure of angle ABC, 112. However, there's multiple ways to do this. You could also start it with this 34-degree angle. And remember that the diagonals in a rhombus are perpendicular, which means that this will be a 90-degree angle. Then you can use the fact that a triangle adds up to 180 degrees to find the third angle of this triangle right here. 180 minus 90 minus 34 leaves us with 56. This will also be 56 degrees, again, because the diagonals of a rhombus bisect the angles. Since these are both 56, again, as part of a rhombus, you know that these are this angle here and this angle here is alternate interior. Okay, 56 degrees. This one will also be 56 degrees. And 56 plus 56 gives us a total amount of angle ABC of 112. And there are many other ways to look at this question. Let's take a look at 17 next. If the measure of angle BFC is 120 minus 4x. Let's measure that. BFC is 120 minus 4x. Find x. Well, we're given no other information, but that's okay. This is all we need. Remember from question 15 that the diagonals of a rhombus are perpendicular, which means that they're a 90-degree angle. So we can write an equation of 120 minus 4x should equal 90 degrees. And if you solve that equation, you should end up with x equals 7.5. So for 17, x equals 7.5. Or again, you could have 7.5 written as a mixed number with a fraction. For 18, if measure of angle BAC is 4x plus 6, let's mark that here. So BAC, this right here is 4x plus 6. And the measure of angle ACD is 12x minus 18. So ACD is 12x minus 18. What will x be? Well, let's think. This problem looks awfully similar to question 14, where we had the 28-degree angles. And in fact, they're all very similar. You've got these two parallel lines as part of your rhombus, and you've got this transversal, okay, that creates two alternate interior angles. And just like in 14, the alternate interior angles are congruent. So you can write the equation 4x plus 6 equals 12x minus 18. And if you solve that equation, you should be left with x equals 3. So x equals 3 for number 18. Question 19. This is my favorite question in this entire packet. If QRST is a rectangle and RX is congruent to QT, find the measure of TXS. Now this looks a little more difficult because there are absolutely no numbers given. But let's start marking the diagram with the little information we are given and see if we can make something out of it. We know that RX is congruent to QT. That's what we know. Well, we could fill in some more information about the sides here by knowing a little bit about rectangles. In a rectangle, remember, we know that all the diagonals are congruent. So if this is one tick mark, then all of the other diagonals can also get one tick mark because they're all congruent. We also know that the opposite sides are congruent. So if this side QT has one tick mark, RS can also have one tick mark. And now, if you look a little closely here, you can see that triangle QTX is not just any ordinary triangle. All three sides are congruent, which means it's equilateral. And what do we know about equilateral triangles? We know that all the angles in an equilateral triangle are exactly 60 degrees. 60 degrees, where it's 180 divided three ways, equally. And now we can find the measure of angle TXS. That is TXS, that's this angle right here. If this is 60 degrees, we can simply subtract from 180 because these two angles are supplementary. 60 minus 180 leaves us with 120 degrees. And so from knowing nothing about the numbers, the values of any of the angles, we can deduce that TXS is 120 degrees simply by recognizing that QTX is equilateral. Question 20. ABCD is a rectangle. Find the length of each diagonal if AC equals 2 times quantity x minus 3 and BD equals x plus 5. Let's draw a quick diagram of this to understand what's going on. So here's our rectangle. A, B, C, D. Remember, the vertices must go in that order because that's the order that they gave it to me in the problem, A, B, C, D. So we've got diagonals, AC and DB. Now you don't have to draw a diagram to remember that the diagonals of a rectangle are congruent, which means that this length right here in blue, DB, is going to be congruent to this length right here in red, AC. So we can take the two values we're given, the two expressions we're given, and set them equal to each other because, again, they'll be congruent. So 2 times x minus 3 equals x plus 5. And if you distribute that 2 and solve the equation, you'll end up with x equals 11. Question 21. ABCD is an isosceles trapezoid. Again, let's draw the diagram of that. So we've got this isosceles trapezoid here, A, B, C, D, with those congruent sides and those parallel sides. Find each diagonal if AC equals 3C over 9 and BD equals 4 minus C. Now, again, in an isosceles trapezoid, similar to in a rectangle, the diagonals DB and AC will be congruent. So just like in question 20, we can set these two values equal to each other. 3C over 9 equals 4 minus C. Now, since you might be unfamiliar with what to do with this kind of equation, we'll take it one step further. If you are dividing by a number on one side of the equation, to start to solve this, you need to undo or use the inverse operation to get rid of that divide by 9. So the inverse of dividing by 9 is, of course, multiplying by 9. So we can take both sides and multiply both sides entirely by 9. Now, multiplying by 9 and dividing by 9 are inverse operations, and they will cancel each other out. So on this side, you're left with 3c. Whereas on the other side, there is no divide by 9 to cancel out. So we can just distribute this 9 to both the 4 and the minus c. 4 times 9 is 36 minus 4c. And now hopefully you can solve the equation from there and end with c equals 3. Note that you could also choose to simplify this 3c over 9 and write it as 1c over 3, and do the equation that way by multiplying both sides by 3. But that's just another option that is open to you. In question 22, we need to label all the missing angles in the trapezoids and kites. So to start, we've got this isosceles trapezoid. In isosceles trapezoid, we know that the base angles are congruent, which means that angle J will be congruent to angle M. They'll both be 44 degrees. In addition, in any trapezoid, we know that these consecutive angles, angle J and angle K, are supplementary. They add up to 180 degrees. That's again because we've got two parallel lines, and they act as same-side interior angles. So 44 minus 180 is 136. In the next one, it is no longer an isosceles trapezoid, so we can't just use base angles. This angle will not be the same as this angle, so angle L is not 78 degrees. However, the fact that the two consecutive angles, angle K and angle J, add up to 180 degrees and are supplementary is still the same. So 78 minus 180 leaves us with 102 degrees for J. And taking angle M, 132 degrees minus 180 leaves us with 48 degrees. Again, the base angles here are not congruent like they were in the first one because it is not an isosceles trapezoid. Two things. First, that all the angles in any quadrilateral sum to 360 degrees. Second, that these opposite angles, such as G and E, will be congruent in any kite. So what we can do is take the angles we already know, 120 and 50, and subtract them from 360. Then we can divide that answer by 2 to get what G and E individually would be. And that will be 95 degrees. For this next one, we know that F is congruent to H. So since F is a right angle, 90 degrees, H will also be 90 degrees. We know that the entire kite sums to 360 degrees, so we can take 360, subtract out 90 for H, 110 for E, and 90 for F, and we're left with 70 degrees for G. Number 23 is an error analysis. A student says that a parallelogram ABCD is an isosceles trapezoid because AB is parallel to DC and AD is congruent to BC. Explain what's wrong with this reasoning. Well, I could see what they were thinking, because an isosceles trapezoid has one pair of parallel sides and one pair of congruent sides. However, in this case, this is not an isosceles trapezoid. Here's why. If AD is congruent to BC, such that AD is parallel to BC, so if you draw this in such a way that these end up being parallel to each other, or such that the opposite angles, such as A and C or D and B, end up being equal or congruent, then you've created a parallelogram, and this is no longer an isosceles trapezoid because you've got two pairs of parallel sides. An isosceles trapezoid has to be created such that these two sides, BC and AD, are congruent, but they are not parallel. If you try and draw out the way that this shape is drawn, they are parallel, and that creates a parallelogram, not a trapezoid. 24. What are the lengths of the sides of each kite? Give your answer in both simplest radical form and round to the nearest hundredth. The thing you've got to remember about kites for this is that, similar to rhombuses, the diagonals are perpendicular, which means that I can put a right angle there and also a right angle here. Now this is very convenient because now what we've created is a whole bunch of right triangles, such as this right triangle here. And what do we know about right triangles? Well, if we've got the length of the two legs, such as 4 and 5, we can use Pythagorean theorem to figure out the length of the hypotenuse. Here's a sample set of calculations. We would have 4 squared plus 5 squared equals fg squared, because fg is the hypotenuse here. Solving that, we would get that fg is the square root of 41, or we could round that to 6.40 if we drop that in our calculator. Note that since this triangle also has legs of 4 and 5, EF will be the same length as FG. Here are the remainder of the calculations for both of the kites in this problem. Remember, one leg squared plus the other leg squared equals the hypotenuse squared. That's the Pythagorean theorem. We'll leave question 25 for the next video because it's a little more involved.